towards us. You're not gonna tell me anyway, right?
I think we're still in the middle of one. We had a bounce, but we're still.
We're still working on problems, right?
That's what I think.
I think so too. We'll
You
just
just
do
want-
that, because the only thing we've got left, pretty much, is the change base formula.
Alright, here's the pizza stain on my thing, so now I remember. Okay, so
We got a pizza stain, so we're progressing with the memory. All right, 110.
we learned about natural log.
Yeah, we did natural log, which is the same property, so I'm not worried about that. Let me just pull up.
And we learned anytime you see an exponent of x, you're going to either have to take the exponent or the natural log.
And this is chapter 4, right? Y'all gotta tell me what chapter it is, I forget.
Four 4.1, I think.
I think
That was
it
3.9.
does.
Yeah, that was
5.4.
4.1. That's the last thing I wrote down.
I was thinking we were in section 4, whether chapter 5 or chapter 4. I don't know which chapter it was, but I remember section 4. We'll find out here in just a second. But I think we're finishing up the chapter. It's chapter 5. I thought it was. 5.4 should be logarithm functions, logarithm equations. There we go. Yeah, we did all those type questions. Yep. We did those. That's definition of logarithm. We did those. Exponential equations. That's what we were doing. We were doing exponential equations, which we did all those type equations. Yeah. All right, just for memory purposes, let's do number, which ones do y'all have the answers for? The even ones or the odd ones? Huh? Odds. Let's try 58 or 55 and 57. Let's try those two. 55 and 57. I'll blow it up for you. And just for memory purposes, let's just do two of them, and then we'll move forward. 55 and 57.
What's it equal to?
What?
Does it equal 1? 55?
I'm sorry, hold on. 55 says log base 5 of x equal 1. Yeah. Log base 5 of x plus 2 plus log base 5 of x minus 2 is equal to 1. on in. All right, the first one, I forgot which one I said, I guess 55. First thing you notice is that these two are to the same one, same base. So that means that we can rewrite that as log base 5 of x plus 2 times what? X minus 2 is equal to 1. And that looks like to me, you can rewrite it as 1 is equal to log base 5 of x plus 2 times x plus 2, vice versa. And that's y is equal to log base A of what? X. And this yields, I can't write, this equals or yields A to the y is equal to what? X. So, if that does that, sorry, that's my son, oh Lord. I hope my mother hadn't forgot to pick him up. Go ahead and finish that now. Sorry about this. This is one of those calls that would constitute as an emergency.
Is that a V or a Y at the second line? Is that a V or a Y?
Yeah, that was, he can't find his telegram. Sorry, I thought he was standing at the front door of the elementary school with DSS coming down. I didn't know. All right, so y is equal to 1, a is equal to 5, and x is equal to all that. So a to the y is going to be 5 to the what? 5 to the 1 is equal to x plus 2 times x minus 2. The reason I'm using a little bit darker, a little bit bolder, is because some students said that on the video, for the 1 or 2 students that actually watched the videos, that it shows up better. So that's what I'm doing. So 5 to the first power is 5. Is equal to x squared minus what? 4, shortcut number 3. And you can solve this 2 different ways. You could set equal to 0 and solve, which give you the same answer as if you brought the 4 over. So 5 plus 4 is equal to x squared. 9 is equal to x squared. So what is the final answer?
3.
X is equal to positive or negative 3. And in this case, 3 is our answer because you can't take the log of what? Of a negative number. So if you go back to the original, let's go back to the original. Let's see. Negative 3 plus 2 is what?
-1.
And negative 3 minus 2 is? So that would cause a problem. So your answer would be 3. So positive 3 is your answer. So as I told you before, you've got to know your properties, you've got to know how to use the properties, and you've got to know the algebra. Now our other problem is 7? Now the only difference in 55 and 57 is that the right-hand side is also log base 7. And on that one, it wasn't. So log base 7 of these two guys, I'm just going to write everything out right now. 4x minus log base 7 of x plus 3 is equal to log base 7 of x. Now, if these two are written as a negative, how else can we rewrite this? As what? As division using what law? Starts with a Q. Quotient law, quotient rule of 4x over x plus 3 equals log base 7 of x. Now what's the rule here? It looks complicated, so let's quit. Is that the rule? What's the rule? Why?
Because they're at the same base.
Because they have the same base and you have you have variables here. So that means, and if there was a number here, then you could set that equal to the number or whatever. If you have the same base on both sides of the equal sign, then this guy is equal to this guy. So that's going to be 4x over x plus 3 is equal to x. My stylus has not been working too good today. Somebody stole the styluses out of 236 today.
What?
I guess they were trying to be funny.
But a teacher have to go with it, it's bad.
No, there was 3 of them. Because somebody stolen them before. I think somebody's trying to be funny.
Is there cameras or something?
Well, the security is going to be doing something. Oh, what are you in for? Oh, I was stealing styluses.
Now you're gonna get raped for it.
X plus 3 cancels, you get 4x is equal to x times x plus 3. 4x is equal to x squared plus 3x. And bring the 4x over, minus 4x. We get 0 is equal to x squared minus x. 0 is equal to x times x minus 1. X is equal to 0, or x is equal to what? 1? Now go back to the original to make sure that you don't get a negative. And 0, 0 plus 3, that's okay, that's okay. Looks like to me that that's the answer, 0 and 1. Now, make sure you can go both ways. Make sure that you can change a logarithm into a exponent, and make sure you can change an equation into a property, or a property into an equation. And you should be able to do that with the homework in 5.4. Those are the questions that I would probably focus on right here in the book, if you're working in the book. What would you do with this one right here before you even started?
Square root of the other side. Square. Square it, give it the
You
square
could
root.
rewrite the log of x to the what power?
1/2.
1/2 power. You could do that. You could square both sides, but that's not going to help you. We'll give you a 2 over here that you could move out front. You could do that. I'd either square both sides or rewrite the log base x, or log of x, to the 1/2 power. I would do one of those 2 things. And the only reason I bring that one up is I would give you that test question, not just so you could pass Math 110, but I'd give you a bunch of these on the test and homework, because whenever you see a radical, you need to learn to what? Rewrite it as a rational exponent, because that's what you're going to have to do in calculus. Okay. Let's solve a couple of these formulas right quick. These are just solving formulas. So, let's do 71 and 75. Now this is just algebra and logarithms. So, hold on a second. 71 and 75. And that's negative KT right there. And this is negative CX right there. on these type problems, you have to know your logarithmic rules, but before you even start the problem, you gotta know how to do what? Algebra. Alright, T is equal to T sub O plus parentheses T sub 1 minus T sub O times 10 to the negative K T power. Now the first thing I'm going to do is get this T sub O over here, get it out of the way. So that's T minus T sub O is equal to 10 to the negative KT times T sub 1 minus T sub O. Now what else can we do to get the, all we care about is that little t, that lowercase t. We care less about the uppercase or the capital T's. So what can we do to get rid of a bunch of junk? What could we do? Say again? Divide by what? Divide by Tito over here. Ti minus T sub O. Divided by T sub I minus T sub O. Better than that. So now we've got T minus T sub O over T sub 1 minus T sub O, and that's equal to 10 to the negative KT power. Now what? What is the log that you would use here? Because you know you don't have to take the log of both sides, because you got to get, remember when I told you that your exponent, where is my exponent that we're solving for? I'm sorry. Where is my variable that we're solving for? Where is it? It's an exponent. And what did I tell you when you have an exponent, when you have a variable that you're solving for, and it's in the exponent, what I tell you you're going to have to end up doing? You got to bring that, you got to bring this exponent where? Back down here. Why? Because you can't solve an exponent when it's up here. A variable when it's up here. You have to bring it down to the first floor. And the only way to do that is by doing what? Taking the natural log or LOG. Which one am I going to do?
LOG.
Why?
That's easier.
It's log base what?
10.
And that would be log base 10 of what? Which is an identity. So, let's take that across. It'd be nice if this thing would. There. I couldn't do that in a million years if I tried. There we go. So I'm going to take log base 10, which is, I'm going to write it out. Log base 10 of t minus t sub o over t dou is equal to log base 10 of 10 to the negative kt power. Now what's the rule when the base is equal to this guy? Huh?
1.
Should be. Just to make sure, we'll go back and pull up our handy dandy sheet's real easy to pull up. You just go to Google and pull up dang old identity. Let's go to, hello, let's go to log rules. Basic log rules. There we go. There we go. There we go. That's the one I'm looking for. Look what happens when you do log base A of A. What do you get? Well, you get 1. But if you have log base A of A to the x, what do you get? So what does that exponent do? It comes down to the first floor. It comes down to here. So not ours is not x, it's what? Dang old kx, isn't it? Kt or whatever. So using this rule right here, whatever's in this exponent will come what? Down. And that's what you want. So since I took the log of this guy basically turns, this right here turns to negative k times t, and this turns to all this. Log base 10, or log of t minus t sub o over t sub 1 minus t sub o is equal to negative kt. And now how do you get rid of multiplying by negative k? Divide by negative k, Hubert. That's right, class. So t is equal to what? All that trash. Print day?
Will that be in the test?
Probably. Any of the solving. Because how much, let me ask you a question. How much logarithmic rules are on this in percentage? 10%. What's the rest of it? Algebra. Trying to let y'all know what the secret to passing calculus is. It's not learning calculus, it's about make sure your algebra, you know it. If you don't know your algebra, you're going to have a hard time. All right, which one did I say, 75?
Yes.
Okay, let's do it. That's the same type problem. In fact, it's exactly the same. Not exactly.
Does that say minus
It
C
says
X?
y is equal to capital A plus capital B times 1 minus e to the negative capital C little x, close parentheses.
Thank you.
Yeah, this problem I quit. Dang old E. That's just too much to think about. wish it was log phase 10, that way I could do it. That was a hint. See, Mr. Sam knows what to do. When he can't do it, he quits and leaves.
I'm out of it.
That's what I'm trying to teach all y'all to do, and y'all won't follow along. Y'all keep trying. God. Keep trying to be determined. Y'all suck. A whole lot easier to quit. Y is equal to A plus B times 1 minus E to the negative CX. And right now, I'm not even concerned about what we're solving for because I got to uncluster some of this. And the first thing I'm going to do is bring the A, what? Over. Y minus capital A is equal to B times 1 minus E to the negative CX. And I know dang well it's not going to be solving for B because that's too easy. That would be like pre-algebra.